So, I'm Thomas Piekarski. I'm a software engineer with a cute company. And we are going to talk about model-based testing today. And I just want to start in a more casual way, relaxing way, just to cheer you up and tell you a little story. Maybe you witnessed on your very own as well. So, it's 1 p.m. You're working with your colleagues and it's time to eat. You go out for lunch, and in the restaurant, after you have eaten, you order an espresso and start talking about the latest issue, the latest feature you're developing. And one of your colleagues starts to draw this. First you think, what is this? But all of a sudden, your attention is attracted to all these little figures with squares, these circles, and what your colleague is trying to do is to map his idea, his mind, onto a little model that he draws. He tries to explain you in a more visual way something he is not able to tell you with his own words. And you think, this might work. This might work. Later that day, you're about to travel, and once more, this time another venue, but the same concept. You're at the airport in Munich, and your connecting flight is running late. And once more, this colleague is just scribbling around at 11 p.m. in a bar. And now, all of a sudden, you know what he means. And I hope it's not the alcohol that enabled him to see clearly. So, let's get started. So, this talk, this session is about the question, what are models good for? And we will just try to approach this question with a set of other questions and a live demo. And let's get started. So the first question would be, what? What is model-based testing? What is complexity? What is abstraction? How do we leverage this? Do we leverage it to our benefit or not? We will take a brief look at models and finally, what is model-based testing? The second question is how? How we are going to model. What is the concept? What we, Qt, can offer you in this particular case. And then, let's get hands-on and let's model a little model for model-based testing. So, the third part is, what was that again? We will recap and wrap up and take a look at our final model, and what is most important to me, that you get out here to the little break we have afterwards with 5 most important key takeaways. So, and the fourth one is a Q&A, and I much welcome you to discuss this issue, this model-based testing. And there will be also plenty of room for questions and discussions, and afterwards, of course, as well. So, let's get started. What are models? How we can model, and in general, let's start with the first term, I think. What is complexity? Complexity is composed of many interconnected parts and is characterized by a very involved, and the highlight is very involved arrangement of those parts. Let's just settle this term for a little bit. And the second one is abstraction. What is abstraction? Abstraction is the act of considering something as a general quality or characteristic apart from concrete realities, specific objects, or actual instances. let's just compare this, but in a more visual way, because we are about to model. So, on the one side, we have complexity, and on the other side, we have abstraction. And I'm sure in a lot of discussions, you just walk from here to here, and I'm sure once more back. So you just flipper between these two, just like the flipper machines outside we used to play yesterday. So there's one more term I would like to introduce. I used it quite often by now. I hope it wasn't every third word I used. It's the word model. So what is a model? It is a representation. It is generally in miniature to show the construction or the appearance of something. And this something, I think, can be our mind, an idea for an issue, an idea for a new feature, or maybe your next startup. But in this session, it is more down to earth, so to speak. It is the application and the tests we want to run. So imagine you walk through your application. There's a workflow you follow. You click buttons, you move sliders, maybe you face a bug. But it's a flow. So, and this flow of user interaction in a UI application, you can model. And from this model, you can generate test cases. So, there are different ways to model things and different model languages. And I'm very sure you have seen this, UML, the Unified Modeling Language. Once promised to be, I don't know, the solution to it all when it was introduced some 20 or 30 years ago. But I'm sure you remember this. These are class diagrams, and early on, when you concept your software, it has value. But I personally, you keep updating them, and once you stop updating them, they get out of date, and well, it's a nice snapshot, like the web archive makes from websites. And some years in the future, you will take a look and think, now, that was promising, and look where we ended. I mean, next thing is, what I think most valuable is this use case diagram. You discuss with business, you discuss with stakeholders what is there to implement. You discuss in a more graphical way the requirements. And next to this is the sequence diagram. Actually, this is really the one I still using when, for example, when I dig into foreign, strange, and alien code. I like to draw things. First, I scribble a list of a call stack where we jump around, and then I start even to draw that. And I like that, because it helps me understanding how a stack of software works, and how and where can I fix a bug. Next to this is a much more generalized approach. It's called SysML, and this is for a broader scope. UML, these few charts I showed, there are a lot more of them. SysML, in contrast, is a modeling language with where you can model, I wouldn't say everything, but most of the things, I think. Is more agnostic to the system you model, so to speak. So where UML is focused on software development, SysML is more generic, and it's based upon the unified modeling language. But there's one third very promising and very famous modeling language. It's business process model and notation. And when it comes down to business, to sales, numbers, that's the way to go. And the perspective is a little bit different in this BPMN diagrams. It's a constant flow. We flow from right to left, or from left to right. And we pass different stages in our business. So these are just 3 examples of modeling language. And let's just face the benefits, the possible benefits you can gain when you use one of these languages or the language we offer with our tooling, which we will take a look afterwards. So, one of the first benefits is it improves communication. Hey, at 1 p.m. at lunch, you started to talk with each other. And sometimes this is the most critical thing, that developers start talking with them, not by commit messages, but in real life and in person. You start to exchange things, and you start also to read faces and read emotions. And maybe then it improves communication, and then you just pull in another tool, a powerful tool to draw. You take the pencil and start scribbling, or take a pen and start at the whiteboard. When was the last time you draw something fancy at the whiteboard? So, we start to talk, we improve the communication, and we communicate earlier than we implement. And this is very important because, requirements do change. How we software developers would love fixed requirements without any change. And, well, we are 3 days close to release, and one of our sales reps just comes in and tells, hey, you have to change this. It will make a huge profit. Management is all excited, and yes, we do. Yes, we do. But I think this is one of the most interesting challenges we face as software developers. So, the next one is we can start testing early. We can start to think how to test a piece of software even before it is written, before it is implemented, and before the compiler was just nagging about some warnings. And you know that saying, the later you find a bug in a software project, the more expensive it gets. And, well, when it comes to budget, we have to improve the way we work and fight the bugs as early as possible. So, reusability, modularity, however you call it, it is a promise. And, well, from my experience, I don't know. Sometimes I think there is the chance to reuse something, but the more time passes by, the less likely it is, and we love to reinvent the wheel. But in general, model-based testing promises or enables you to some degree to reuse your models. You model once, and down the road, in the long run, you can constantly reuse the same models. Of course, you will have to tweak here and there, and with our tooling, I think you most likely will need to tweak some identifying symbolic names, but hey, that's a fast one. So, it supports automation. Just run Jenkins, and it will be green. The next one is, well, controversial. It can reduce the cost of maintenance. How? How do you think it could reduce the cost of maintenance? When I'm about to first to draw, then to create models, then create test cases. But wait, you create test cases. So You create one model, and from this model, you can create different test cases. Imagine you walk the path through the model. You go straight, you turn left, you turn right. Hell, maybe you will get lost during your walk through your model. But it can reduce the maintenance costs when it is applied in a good way. And next to this, what is most important, it can enhance the way you cope with complexity. We live in a rather complex world, and it gets more and more complex every day. And our software projects are complex. And when you draw something, you try to abstract. And the terms we just introduced at the beginning, it's just a fight between complexity and abstraction. And you just ping pong between these two poles. So, but, well, where's light? There's of course shadow, and there are of course drawbacks. And I won't neglect that there are. The first one, you will need additional knowledge, and you will need to acquire certain skills. And when it comes down to modeling, I have sometimes the feeling it's more open to people, definitely, and it will improve the way of communication. When on a whiteboard, when somebody sees a model, it is way easier to get into it. Even people from marketing will drop by. Maybe we'll make it fancy, more fancy, or salespeople or management will get to the whiteboard, and they will be able to follow it. But this should not be neglected, that it is still a skill required to put model-based testing into action. And I'm sure I see here a few people which tried, and I'm sure a few of you have been successful, but a few maybe haven't been successful in introducing model-based testing. Explosion, it's called, and it's from one model, you can generate a few test cases, but you can also generate thousands, maybe even millions. And especially, in the talk before, the automated testing, autonomous testing, you can really generate a lot of different test cases. And this sheer amount can explode. And you're close to the release, and you're supposed to run 1 million tests. I mean, DevOps won't be that happy to hear that. So, one major drawback is the inefficiency due to too many test cases. Yeah, it can increase maintenance cost, and it can also increase complexity. But wait, something odd here, don't you think? These last two bullet points contradict each other. And these two contradicting bullet points comes down to this. It's what you expect from model-based testing versus how do you apply model-based testing. On the one hand, it can increase maintenance costs, but on the other hand, it can decrease the costs. And, well, on the one side, you will lose the battle against complexity, but on the other side, you will be victorious and win this battle. So I will settle your expectations a little bit, or I will try with a little demo we will just run now, because I hope when you try model-based testing, you won't introduce new complexity, because it's very easy to introduce a lot of different layers in complexity when you draw something on a whiteboard. This arrow here. This new rectangle we need. Here a database. Here some RPC communication, or whatever. I mean, a model is easy drawn, but when it comes to implementation. How? That will be tricky. So let's get to the how. How we are going to do it. What our tooling, what our product is introducing is this three simple components you can draw. The first component is just the start. We all started today maybe in the hotel or at home, and this is the point where the model starts. The next, it's obvious, it's a step. It's a step. This is a generalized activity and describes what to do. And in between those steps, of course, the starting connection, a starting point, are the connections, which is a directed graph which shows you the way. So let's just take a look at our first model. We start and we make a step. It is very abstract, I know, and I'm sure a few of you will now think, that's too easy. This doesn't fit my system. This never will. But it's a starting point. And a model is just, you visualize your idea, you visualize your application, and it's a starting point, and you can start creating models. And this is another example of a model, rather simple one. And here, from this little model, with its 9 steps, we will generate test cases. We walk the path. First, let's proceed to the 4th step over there. That looks decent, and it worked out. The next one, we will take a detour and turn right at the first step, and finally finish at step 7. And the third one, we will completely detour and finish with step 9. So this is how you generate test cases. You have one generalized model, and you walk the path. You make step by step, and here we have 3 exemplary test cases we just chose. I'm sure you already have seen 1, 2 more, but it's up to us to choose. And here you can, of course, you can make it manually, but in the future, in the next years to come, we will support you to automatically choose the paths. There are different algorithms we can use, and our tooling, Squish, can support you with that. And well, once more I forgot. So all those rectangles doesn't remind you about this? Me a little bit, but I'm sorry, we won't talk about Docker, not this time. We will just talk about the demo now. And what we are going to use is in Qt Creator. Qt Creator is offering multiple different sample applications to showcase different features, and we will use the robot arm example to model the loading of cargo, of all those containers, all those steps, so to speak. And I will just briefly show you the application. So here we are, and it's just rather a straightforward application. What you can do is move this robot arm around. You have 4, we have 4 different rotations, and we can move them in a specific range. And let's just try something. We have presets here, pose 1, pose 2, and when we move it like this around, we have the possibility to alter it. And what we have, which is rather important when it comes to testing, we can reset to a specific initial position. Next to this, of course, we have a claw, and we can claw things. I like that. And we can unclaw and release the cargo. So this is the little demo application we can use, and you can find it in here in Qt Creator when you go to examples and start a robot arm. So it's a Qt Quick application which you can use. I'm mentioning this because there's a demo repository I will introduce after, before the Q&A session, where you can also download all the demos, all the models we just created, and it will be also kept updated. But this is for later. And so now let's just model and test the loading of some cargo. So here we have Squish, and this is the Squish IDE. It's a front end, so to speak, an integrated development environment where you create, usually you program or code your tests. You can record and replay your tests. It's very alpha, what I'm showing here. It's just a compiled thing from commits I pulled a few days ago. So what we have here is, on this side, we have different test cases, which we will talk later. And here, down here, we have the models. Here we have the models. And in this area, we have the graph area where we can start drawing. We can create and add steps and connect them. So let's start with the first one. And like it was before, we better reset the robot arm to an initial position. Well, let's go with reset robot arm. So we switch to edit mode, and now we can save, move this. And maybe you will just think why this is highlighted with a rectangle. It just warns you that the step you created is not yet connected. So let's just do that. Zoop. Okay, it's connected, so we have a clean reset position where we can start. So the next step would be, we need to change the mode. Okay. The next step is, let's maybe check for pending cargo. Is there something we need to lift off? Pending cargo. Okay, the next step would be, let's see. I think move the robot arm to the cargo. The next step we would use is, you remember maybe this claw we used, so we need to claw the cargo. And finally, we move the cargo to a final destination. Okay. And the last step, I think, is we unclaw the cargo. Okay, so let's just switch to the edit mode. And let's just arrange that a little bit, because I don't know. I just like to have them all aligned, and soon the Squish IDE will also offer an auto layout option which will arrange those little rectangles in a more nice way. Okay, I won't spend too much time. So let's just switch to the link mode, and let's just connect. We reset the robot arm, but wait. Here we have, for example, the first thing. Why we should reset the robot arm when we not yet have any pending cargo to move? So this is the first thing. We start to see something we need to alter. It's a simple example, but I'm sure you get the idea. So let's just disconnect this and switch the position. Okay, once more, we link, we start, we check for pending cargo, we reset the robot arm, we move the robot arm to the cargo, we claw the cargo and lift it up. The next step would be to move the cargo to the final destination, and we unclaw. And now, we just finish it with check for further pending cargo. So this is a very simple, little, straightforward model. And now you will think maybe, for example, this reset robot arm. How do you connect this with some script, with some code? Because your model should be alive. It should live on its own. And I'm sure it won't. Maybe some models will turn to Frankenstein, but not this little one. So reset arm impl, let's call it. And straight out of here, you can generate the step implementation. And this approach will maybe ring a bell from a few of you. It is a little bit close to BDD, behavior-driven design. And what I personally also think a little bit, it makes it easier for people who are using already BDD in creating tests, creating scenarios, features, and steps to start leveraging model-based testing, because there's much more to come than this, what we call Squish step diagram. We will introduce sequence diagrams and state diagrams, and also embrace also a little bit more UML. And of course, with this, you have the possibility to run those tests. And it's just another way to think about your testing efforts and think in a more visual way. So let's turn back to our presentation. And okay. So, oh, there's one thing I forgot. We have our model, and we just need to generate test cases, actually. Because the question is, what is the model good for when we don't generate some test cases? So we will choose a pre-made little model, which looks a little bit more decent. And here we just create a new MBT test case. Demo 1, we will call it. Oh, let's just choose the one we just created. Okay. No, it's not this one. We should save. Here it is. Okay, so now here we have, it looks almost the same how the modeling editor, but this is the test case editor, and here you have a distinct difference. Here at the sidebar, you can add and remove steps. You create a path. You walk your model. So let's just take a walk. Then, and we start at start, go to check cargo, reset robot arm, and we walk the model, and once more here. Okay, so here we are, and this is one way, of course, which will be offered to you, and in the next time there will be multiple ways to walk this model. But it's for the sake of this demo. And here, at the right sidebar, you see already all the steps collected. Yeah, we should run the demo. We should run the test, but it is alpha software, and it's not yet reliably implemented. But we will be able soon to run that, and the demo repository will be kept updated for you to follow along. And sooner than later, we will meet again, and we will have this feature fully developed, step by step, just like here in this diagram, I think. So let's switch back to the presentation, and let's get to our recap and the 5 key takeaways I promised to give you at the beginning. First, let's take once more a look at our final model. Here, I took the liberty to arrange all in a nice way. So here we have, for example, this little model we created, and it's more or less almost the same, but here is one distinct difference. First, Port Authority told us to check the environment before we start loading cargo. Yes, we should, definitely. And next to this, sometimes we have important cargo on hold, which we need to skip all those steps. So we start right and move robot arm to cargo position. So this just illustrates two additional things to consider when it comes down to change in requirements. And this could reduce the cost of maintenance because you have all modeled and you just add a step to your model. You provide a little implementation. For example, with check for safe environment, you need to pull some HTTP endpoint for JSON payload, for example. You have implemented this already in your application. Here, you have to check that. So you provide this little script implementation to use a mock, or maybe the real thing. Okay, so what are the key takeaways? First, it enables you to early model and test. The next one, it can ease complexity. And I hope you will use model-based testing to ease complexity and not to introduce more complexity, because then you won't convince maybe your other colleagues to use it, because hell, complexity is good sometimes, but sometimes not. And then you can draw all kinds of different models on every kind of napkin you can find. You won't convince anyone. So we leverage abstraction. We just plot our mind into different visual cues. And we improve the communication. We start to talk, we start to draw, we start to release our software in a much, much better way and in much better shape. So, that's it. Are these 4? No, I'll be damned. There's one missing. That's interesting. These are 4 takeaways. The 5th is up to you. You can just take and think for yourself a little bit and just imagine how you could incorporate model-based testing. So now we're done, and now we get to the Q&A session. And here you have a link to the demo repository. It's provided as a public repository at our public Git instance at git.qt.io. This repository contains all the demo materials. The slides will be also uploaded there, and the models, and it will be updated next year. I'll keep that updated, and as soon as more features see the light of day, and when we release our tool, Squish 8.0.0, I will also update this. So you can just follow along and revision that you once stayed in Berlin and loaded some cargo with models. So